Sarah, Jessica, when a gal tells a dad joke, that's a faux pas.
Jeff, I'm started working for 3M as the OT security director, and do you know how computer hackers get away from the scene of a crime?
No.
They ran somewhere.
That's pretty good. That's pretty good. I recently started selling corn on the cob to pirates.
Yeah,
it's a buccaneer.
Hey,
since we're on the
you know why the toilet paper didn't make it across the road?
Stuck in the crack.
Got stuck in the crack.
Well, I was going to stay with the food theme, and
Yeah.
you know why Han Solo spit out his steak, right?
No.
It was chewy.
Ah. Wow.
That's good.
Well, with that,
that's a good one to welcome everybody on. All right. Everybody that's joining, thank you so much for coming into the project. Alan, we are talking about LoRaWAN today, right? How can we make it less complicated to add a LoRa sensor into our environment? And then also, how can we get that data into our control system, and from there, anywhere else that we want to take it? And so this is the follow-up from last week's conversation that we posted on the rundown on our LinkedIn Live feed. And today, we're going to get right into the project build-out. Alan, why don't you introduce our guest?
All right, thanks. As always, Benson Hougland, the Vice President of Marketing for Opto 22. Thank you, Benson, for not just being a part of this, but really setting aside your resources of your team and yourself to help us get to a place where we could have the opportunity to create a wireless infrastructure kind of an architecture that allows us to get that data directly into our control program. So thank you for your efforts here, Benson. It's been, I know that it was way more work. Here's the reality. Every time I ask Benson to do anything, it's always way more work than Benson is bought into, but he always comes all the way through for me. So thank you very much. Terry, Opto 22, Skunkworks genius guy that is also my concierge for all things 3D printing. Again, thank you for being a part of this, Terry, and just again the effort that you put in to help make this what it is. And then our SiteSync people, Jessica, Sarah, go ahead. This first time you've been, I think you were on the last week, but kind of give us a little bit of a background of yourself and just real quickly, high level overview of SiteSync.
Yeah, of course. So I'm Jessica Williams. I have a background in controls engineering, so DCS, PLC. Was brought over to IIoT team, and I've been doing some front end user interface design, just trying to make it as simple as possible. And that's kind of the overarching goal of SiteSync is we take a difficult process of working with LoRaWAN, setting up a system, and I'm going to elaborate more on this later, obviously, but trying to make it a automated, pain-free process to add in devices to your network. I'll let Sarah introduce herself.
And I'm Sarah. I work on the SiteSync product, and I am a data scientist. My passion is automating boring, tedious processes. So coming into something like this and building architecture or apps that can help make these processes less painful is what I like to do. So we've worked together, and it's been a lot of fun on this project. We really enjoyed working with Opto on this.
Awesome. Thanks again for your efforts. I know it's been more work than you anticipated, but again, we are on the path of really, for the first time, probably not the first time, but really allowing our community and the industry to have a touch and feel as if they were putting in a ring doorbell or a Wise security camera, right? Scan a QR code, things just happen. So again, thanks for your efforts here. And I know it's been a lot of fun in the journey and some pain points. So looking
Learned a
forward.
lot. Building stuff out that makes it more easy is why we're here to do it. So I'm glad we did it.
And you got an opportunity to work with a one of the best in class next gen PLCs and the Benson. How much better is that?
It does not get better.
That's right. Jeff, I'm going to hand it back to you. Let's lead us off. I will say, last night I did burn 2,000 calories. That's the last time I leave the brownies in the oven too long.
All right. So we're getting ready to move into live demo, build out of the project. But before we get there, just walk us through what is this business use case? And Sarah, what's the pain that someone would currently experience if they had a new LoRa sensor that they wanted to try to bring into their environment?
Yeah, absolutely. So really the reason that we got started in all of this is because we believe
Sorry,
in
Jessica. I had the wrong cue.
No,
Jessica.
you're totally fine. I got what you meant.
I'm like, why is Jessica talking? That's not Jessica.
I know, going off script. Yeah, so the whole reason that we got started in all of this is because we believe in the incredible power that LoRaWAN offers. And so LoRaWAN, we kind of talked about, it's low power, wide area networking protocol. And it connects your end devices to gateways, pretty much at its simplest explanation. And so the huge deal about LoRaWAN is that it's low range and wide power. And low power, sorry.
Wide range, low power.
Yeah. And so you can actually get a communication distance of up to 6 miles if you have line of sight or like in an ideal communication environment. And so that's an impressive range. You can actually cover like an entire petrochemical plant with 3 to 5 gateways potentially. And so this has wonderful wireless penetration as well through structures. And so this is a really big deal for people in metallic environments. If you're in a warehouse, a building, any industrial setting, it's really able to go through heavy equipment, metal walls. It can make it between floors, even in a plant setting. So the applications, obviously, with all these benefits are endless. And that's something that we're going to get to later on. But if you've ever worked with LoRaWAN, you do know that the amount of time and frustration that goes into trying to get the data from the sensor decoded and formatted and coming into your system correctly and ready to use. And so, well, for those of you who haven't experienced it, I'll kind of describe the manual process and the configuration of a LoRaWAN system. And so you start off by manually connecting to an LNS, which is a LoRaWAN Network Server. And so there's a lot of settings that goes into that, but once you get it set up, you're manually decoding sensor data. And so all the data that comes from a sensor is pretty heavily encrypted, and that's a good thing. It's for security purposes, but it's definitely not plug and play. So you can't connect a sensor and start getting in your values with the right units and everything like that. It's quite a lengthy process to kind of make the funnel that you need to run the data through to have it be constantly being decoded. And so that's an arduous process, but it's also a different decode for just about every sensor that you want to add to your system. And so
just to be clear, you like in the control system space, as Jessica and as we know, right? Mm-hmm. Anytime you buy a device that typically you put into your control system, the protocol that you can always count on being there is Modbus. It typically like, oh yeah, I've got a Modbus address I can just pull out and get it. But this is not the case for LoRaWAN. You have to decode and decide what protocol you're going to decode to, and then you have to be able to program that to get that to that, and then you can go and get to a driver and then pull it in, right?
Exactly. Yeah. No, it takes quite a bit of knowledge on a lot of different components and some programming background to be able to get all of this sensor data where you want it. And so it's definitely not what we're kind of used to in the control system space. So once you get that data decoded, you're formatting the data, and then you're looking for it in your system, and then you're trying to figure out why everything you just did didn't work. And so it's a really painful process. And we felt that manual decoding pain. And so that's really what pushed Sync Automation to create that SiteSync LoRaWAN module. And that module, the goal of it is to automate all of the pain points in this process. And it takes it from this 3 to 5 step process, picking a protocol, decoding all of these different things, to just 2 steps within one environment. And so it really simplifies it. And our goal in doing all this simplification is to make working with industrial IIoT, just like Alan said, just as simple as commercial IIoT with your Blink cameras, Ring doorbells, where you pretty much take it out of the box, scan it, and it's in your system ready to go. And so our other main goal is to take away that burden of scaling the systems, of having to decode every single new sensor that you add, from the digital transformation team, if a company has that, and we know a lot of companies don't, and put this simple deployment in the hands of technicians in the field, where they can install a sensor, scan the QR code, and have it come into the system automatically. And so to kind of describe our module in the way that it works, you start by just filling in a few fields within the module, hitting connect, and your LNS is then connected and ready to go. And then the next thing, if you want to add any end device, it's a simple QR code scan to get that into your network. And that's going to automatically decode your data and get it into the right format and coming into your network ready to use. And so here, I'll show you, right now we're doing paper tags with SiteSync, but we also have the option to do laser engraved stainless steel tags to withstand weather. But this is your QR code that you're looking at to scan, and we're going to show that scan later on. But we are actually working with the LoRa Alliance and sensor manufacturers to try and get, you can see smaller on the back right here. Let's see. There's a QR code that comes on the sensor, but we're working with LoRa Alliance and sensor manufacturers to try and standardize what data comes in that QR code. So we are doing our own QR codes right now to get all the data that we need for the module. But we have a colleague who's Clint Guillory, and he sits on the LoRa Alliance Industrial Working Group. And he's really passionate about getting all of the data that comes in these pre-made QR codes that come on the sensors standardized, so that we can even expand what we offer with our sensor suite, and just have it so that if you buy any sensor that's within the LoRa Alliance, that it's going to work seamlessly with our module. And so now I'm going to show you a few of the background details of our setup. And so I will pan to, let's see. Yeah. So this is kind of our setup. And so the LNS, our LoRaWAN Network Server, is made up of 3 parts. And so it's a join server, a network server, and an app server. So for this demo, we're using an onboard LNS on this MultiTech gateway up top. And so our join server and network server are running on the MultiTech gateway. And then the app server is our SiteSync LoRaWAN module, and it's running right here on this Groove Epic Opto 22. So I'm going to hand it over to Sarah, and she's going to show you just how easy this process is with our module.
One second, I'm sharing my screen. Oh, and I can't share my screen.
Oh yeah, it says host disabled, participant screen sharing.
Oh, sorry, 1 second.
Sorry.
Not a problem. We'll take care of that for you.
So essentially, we installed, let's the laptop. We installed our SiteSync app on the Opto, which is a really simple process. We opened up shell access, installed our app, and it was ready to roll within seconds. It was a really easy process to install and work with. I really enjoyed working with the Opto team on that. It was really open and good. But I'm going to try to share my screen again. Let's see how it goes.
We'll be good now. Zoom defaults were can't share.
Not a problem. All right, see my screen? Excellent. So I've been working with Opto team, Benson, Terry, Ben, all of them, and I'm in group view right now. And this is this Opto right here. Love to see it. And we already have some LoRaWAN sensors already in.
Yep.
You're not sharing yet.
Oh no. Sorry. Let's see what I can do. Let's see. Expand that. There you go. Try again.
There you go.
There we
Got
go.
it.
Awesome.
There we go. Sorry. Okay, now you can see my screen. Perfect. All right, so I am in group view on our Opto. You can see we already have some pre-populated sensors. Let me get that off here. And these are sensors that we already have joined in our network. They are within your group view, which has regular non-LoRaWAN sensor stuff in your control, as well as this wireless technology, which is cool. So we have live data in here. And it's been really simple to get this all set up on the Opto side, really nice. So what I'm gonna do is take you over to the LoRaWAN, I'm gonna take you over to the app that's running on the Opto. This is our SiteSync app, and I'm gonna show you how we're gonna connect our Opto to this MultiTech gateway. So this is our network server, and as Jess was saying, so how do we connect our Opto and make that bridge? So this is an app that's running on the Opto, and this is a configuration that I configure that link to the two. So I am working with a MultiTech gateway. We have different ways you can connect. Basically, I need to connect to an MQTT broker. These sensors all communicate, or this MultiTech gateway exports its data in MQTT. We can do other formats, but most of them use MQTT. So I'm going to pick TCP for this one. This is my broker that I'm connected to, and this gateway is connected to, so it's sending its data up. We've configured our topic, so that could be anything, but this one says any app and any dev UI we need. Don't need authentication in this case because it's in my local setup, my local network. We have a bunch of different network servers that you could use. So we have the MultiTech conduit we're using today. It has the onboard LNS, but we also can use ChirpStack, ThingPart, TTN, Utilities version, and we're open to working with other LNSs. So if you have an existing one, we can definitely find that connection or make that connection. We're really interested in making this as easy to use. So we want to be able to work with things that you already have. But in this case, I have a MultiTech. I'm just going to go through and set that connection. So this is talking to the gateway through an API. And what am I doing here? Why am I doing an API connection? I want to be able to scan or add my devices over into a key store very easily. And I'm using an API connection between the Opto app and the MultiTech gateway. And then we have our export options as well. We are exporting our data into Scratchpad or MMP, and Benson will tell us a little bit more about that, but that is going directly into the memory on the Opto, which is really nice. And you can access that data from this area on the Opto in any of your apps or things running on the Opto, which is really nice. So we're gonna go ahead and submit, and I'm gonna take you over to key management. So this is my MultiTech gateway over here, and this is the joint server of that LoRa network stack. So this is the onboard one for MultiTech, and you can see I have a couple devices in here. LoRaWAN Sensors have a 16-character dev UI, which is like an identifier, and we can tell the last 4 groups of those are here identifying it. So I'm gonna go ahead and add a sensor. I'm gonna scan one in because we already have these sensors here in GroovView. They're reporting, we love to see it, but how do we add a new one into our environment? So I'm gonna take this big level sensor. It ends in 88, if you can see it, but I'm going to come over here. This is our QR sync part, and this is how we quickly and easily add devices both to our decode library here on the Opto, but also into our gateway. So that's me. We've optimized this for phone, but I'm not on a phone today. But it's quick and easy as that. Previously, you'd have to go through here, go through and add like 16 characters, 32 characters. These all come together to do encoding to make your data very secure, part of that encoding. But it's unique to every device. And if you don't key it in correctly, you're in for a bad time. But I'm going to go ahead and submit this. I'm going to sync it over. It's going to take a second because we are right there. But just
we wait for that, Sarah, can I just ask a few questions?
sure thing.
Okay, so if you look at the IP address, 192.168.556, that is the Opto IP address, correct?
That is correct. So this is GroovView running at the same place. It's local on my network.
And the LNS is running on the Opto PLC also, correct?
It's not running on it. It is running
MultiTech.
on top of it. Yeah, it's multi-text.
Okay. Yeah. So my point is this is an on-prem, not connected to the cloud solution.
Correct. This is a closed loop.
Yeah. You can, if you have the ability, you can go to the cloud and use an LNS that's hosted in the cloud or what have you. But this is really around control systems, segmented systems that you're going to be, if you need to do this on-prem, and the only thing you have to know is if you're going to use your phone has to be connected to the same network that the Opto is connected to.
Yes.
Otherwise, you would, and you can do that a couple different ways. Benson can talk about it later, but I'll just quickly say that if you're on the network that has Wi-Fi, it works great. If you need, then we have in the past in certain areas plugged in a USB to Wi-Fi adapter on the Opto, has a USB capabilities, and you can run a wireless network locally there that way too. So just as the filling the gap in between that, how you get your phone connected to the PLC. So
Yes, very cool, and like all on-prem, local, which is great. Nicely portable, but also secure. But yeah.
Yeah, and Sarah, if you want to leave that screen up, actually.
Sure.
So that, as you can see, we have some sensors already coming into our groove view. And so I'm going to talk a little bit about these, show you guys those sensors and give you a few details on each of them. So we have, here, if you want to stop sharing, it'll make my image big.
Sorry.
No, you're fine. Okay, so we have 3 sushi sensors. The first one that we have is this vibration. And so you can see our QR code on it that makes the scan easy. But this one measures vibration along the X, Y, and Z axes, and it also will do temperature where it's mounted. And so that's the first sushi. The next is our sushi temp. And so for this one, it has a dual input IEC standard thermocouples. And that is any of 9 types of thermocouples, and it includes type B, E, J. But for this purpose of our demo, we have this on it that we can heat up the temperature with. But yeah, that one is a cool one. And then our third sushi is our sushi pressure. And so we have it on a gas can right here. But that one is interesting because it will do gauge pressure of gases and liquids in piping, but it also will measure in cans as well, as we're showing. And so you have the gauge right here, and then our data coming in matches what's being read on this gauge pressure. Then our other types of sensors that we have brought in already is we have a VegaPulse Air 23. And this one, it measures a range up to 3 meters, and you can do it on a tank, vessel. You can do it on porta potties, like Michael mentioned last week. But it measures up to 3 meters, accuracy of like plus or minus 5 millimeters. And it's really simple, easy to mount. And then our last one that we have brought in already to our Groove View page is our radio bridge voltage. And so this one we have on a power supply, and it's telling you how many volts are being read. And it measures between 0 and 30 volts with a 10 millivolt precision. So it actually does over-the-air configuration too. So after you get it set up, you can make changes, and it does automatic error reporting as well and reports on change. So that's
another point of talking about LoRaWAN sensors that I'll give a use case that will be helpful here. So one of the things that a water district here in our town is doing is they've currently been running serial radios, 900 megahertz serial radios across their pumping station to the stand tank that they're pumping to, and ultimately, if they lose that serial communication, then they have no control of the fluid that they're pumping in or the fluid that's being taken out of that stand tank. And so, being able to put a LoRaWAN gateway with an Opto at the pumping station, and then put a submersible, level gauge that drops into the tank and gives you a level. Well, now you have a redundant opportunity to control that tank, even if your comm is down on your primary comm. But here's where it gets exciting. And I talked about this last week, but where it gets really exciting is once that infrastructure is set up and you have that gateway and you have the antenna set up and you're starting to communicate, Well, now as they start thinking about, you can go to ThingWorks and you can get a simple transmitter that you strap on a valve, tells you if the valve's open or closed, tells you what percentage the valve's open or closed, tells you if the gate at the pumping station is open, if it's closed. And so you can start to really think about expanding out your network. And the ease of it is you purchase the sensor, you get it, scan the QR code, the data shows up in the PLC, and you're off and running. So that's really what I'm excited about from my standpoint. So
Right. No, the applications of it are endless. And exactly like you said, it offers redundancy. It can offer monitoring of data that you weren't even seeing before. And so the options are just endless at an affordable price. And the other thing to note, so we have about 30 sensors currently decoded in our library. And within the next month, we'll have over 200 in that library. So the goal of this module is really to take away decoding from the end user. And so we're very end user driven as well. And so if you don't see a sensor that you're trying to use in our library, let us know and we can get it added so that you can just easily QR scan and get it in there. But yeah, the applications are very cool. You can get a lot of data that you weren't seeing before.
Jessica, what's just a ballpark range? You mentioned the sensors and cost. And I'm assuming there's a law of scale, but just if you wanted to pick up one or two sensors, what's a typical range that you'd expect on a LoRa sensor?
Yeah, you can get them as cheap as like $100. And I would probably say most of them are under 1,000 to be very safe with that number as well. But you can get little push buttons for very cheap. And you can get things like this just in the $100 range. And so you're getting data that's you haven't seen at a very low price compared to a lot of these other sensors that we're seeing.
I'll give you an idea. So here in Kern County, we have multiple oil companies who have deployed LoRaWAN sensors in their chemical tanks, right? So they have these chemical tanks. They need to constantly have somebody go drive out and look at the tank and get the level. Well, having the windshield time of somebody on the road, there's a safety issue there, and so on and so forth. So some oil companies here in Kern County, what they did was they deployed some LoRaWAN gateways. They bought Class 1 Division 2 ultrasonic level transmitters and put them right in the chemical tanks, and those were under $1,000 for each one of those. So
I've worked on a couple of projects where smart meters for utilities have moved to a LoRa line of sight simply to reduce the windshield time of sending white F-150 around to try to scan those measurements. Yeah.
Good choice of truck.
Yeah. The device that we scanned and joined into our network has checked in and is reporting values. So with that, I'm going to hand it over to Benson and he can show you on groov view, PAC control, all that good stuff.
Terrific. Thank you, Sarah and Jessica, for lining all that out. What I want to do on my part of the presentation, naturally, I'll be talking about the data that's coming in from the software, the SiteSync software that's actually resident on the Epic. For those of you who are unfamiliar with an Epic, what is that thing? Well, it looks like a PLC, acts like a PLC, and indeed is a PLC. But that's like looking at a flip phone and saying that's a phone. And indeed, what the Epic is, and Epic is an acronym for Edge Programmable Industrial Controller. So it really becomes more of a smartphone of PLCs. Now, what do I mean by that? Well, indeed, it runs a PLC program. It's designed, it's Class 1 Div 2. It's designed to be, deployed as you would deploy any PLC. But there's a lot of software and capabilities that are built into the Epic that we want to be able to take advantage of. And I'm going to go over several of those. But what's important to know at first is one of the things about Epic is it's a Linux system, a real-time Linux-based OS. And because of that, we have a feature, if you will, of being able to access the file operating system, the operating system itself, and install your own programs, right? So just like your smartphone, it comes with a bunch of applications pre-installed, and Epic is the same way. But if you want to install other applications, there's a method to do so, and that's called shell access. It's free. You just click the button and boom, you've got it. And that's what the folks at SiteSync have done. They've enabled shell access. They've taken their SiteSync module and installed it on the Epic. And then that's what we saw with Sarah and Jessica. They were logged into their own application running on the Epic and setting that app server up to, again, configure the MultiTech gateway, to do the QR codes and all that. Okay, terrific. So now we got the data in SiteSync running on the Epic. But how do we now expose all that data to all the other applications that are available? And applications include the control program. In this case, we're using PAC Control, which is our own flowchart-based language. But unlike other PLCs, you actually have a choice in which programming language you want to use. So for example, we also have CodeSys on there. So we wanted to make the data available also to CodeSys. We've got Node-RED, we've got Ignition, we've got the groov view HMI, which you've already seen. So there's a lot of applications there that we want to get the data to. So what's the best way to do that? Well, we could, make SiteSync a Modbus server, and then we'd have to, create Modbus tags and so on to make that work. And that certainly could be an option. But what we found was the best approach here was to actually take the data from all the sensors and deposit it into a memory area. And that memory area is something we call Opto MMP. So what I'm going to do first is just bring up the diagram that we showed last week. And so indeed here we now have the LoRaWAN MultiTech gateway. This is your LNS, okay? And then the app server is up here on SiteSync running on the Epic. So now that this connection's all been made, and Sarah has shown how she's logged into the LoRaWAN, configured it to communicate with the Epic, the SiteSync software running on the Epic. Now we're going to start playing around with some of this other software and getting that data. So again, where is the data? Well, that Opto MMP area is where it is. What is Opto MMP? Well, a short history. When we first came out with Ethernet IO back in the 90s, there was no Ethernet IO protocol, not even Modbus TCP. So we actually had to come up with something that we could use with our Ethernet IO. We came up with Opto MMP, and what it is an IEEE 1394 standard. And for those Mac heads that may be in the audience, or if you've ever dealt with something called FireWire, that is the same protocol. So the protocol that's built into all the Epics and Rios is this Opto MMP. So what's cool here is what SiteSync has done is taken all that data and moved the process variables directly into that MMP area. That means that any piece of software on the Epic can now access that area, those process variables, and pull them in. But process variables is not the whole story. We need some context. We need some metadata. So the other cool thing that the folks at SiteSync have done has, whenever they bring on a new sensor, they create a JSON file. JSON is just a JavaScript object notation file. It's human readable, key value pairs, and they take that file and they write it into the file area on the Epic. It has a full, file operating system. I can view files and so on. So what I'll first do is I'm going to log into the Epic, and then I'm going to show you that JSON file that they created when a new sensor came online. And in that file, it's going to give me all of those Opto MMP scratchpad areas where I can find the process variables and integrate that right into my control program. Once it's done there, there's all kinds of cool things. All this northbound stuff I can start doing. I can move data on-prem to cloud to devices and so on. So let's just jump right in. Now, there's one thing that I want to show you before I get started. There's something here called OpenVPN. Well, this is kind of cool because Sarah and Jessica are in Baton Rouge, Louisiana. I'm here in Temecula, California at our headquarters. So how in the world am I going to make a connection to the Epic? OpenVPN. There's an OpenVPN file here, and their Epic sitting in Baton Rouge is connected on an outbound path, outbound only, no inbound ports, outbound to connect to an OpenVPN server. Then I'm connected to that same VPN server. So now I can access their Epic with my own account from anywhere in the world. And today I'm going to do that from Temecula. So I'm going to come up here. I've got a shortcut.
Does that mean are you getting ready to give us a Garth Brooks impersonation then?
You can do it better than me, but calling Baton Rouge. That's the best I got. That's the best I got. All right. So good one there. So now I am indeed calling Baton Rouge. and I'm presented with a screen. I've literally connected to their Epic from my desktop here in Temecula. And also what Sarah and Jessica did was create an account for me on the Epic, because there's a lot, you can have as many accounts as you like and set up different rights and permissions. And they've given me administrator access to this Epic and with a username and password. And the good news here is when my work is done, they just delete that account and I can no longer access this device. So that's pretty cool. So I'll log in with my own account.
That you can also, which is something that is very near and dear to my heart, you can use LDAP, right? So instead of having to manage a bunch of, individual accounts on different PLCs, you can tie this to your LDAP settings. You can then give the groups the rights, and then now you just manage your main username and password.
That's true. So I am using the local accounts on the Epic in this case, but just as Alan described, I can have those accounts being managed centrally by IT through an LDAP server. And that would, of course, assume that the Epic is connected to that LDAP server, and that's pretty obvious. So we've got the different users in there. There's some in there now, including ones that are just groov, some other that are system-wide administrators, including one for Terry because he developed a really cool Node-RED flow. I'll get to that in a moment. So my accounts are set up. I'm clearly have a secure connection, not only to the device, but also through the VPN tunnel. So I think that's important because as we start talking about democratizing data and putting devices out there, it's absolutely imperative that at an OT level that we're securing all of those systems, that the only way to access them is over encrypted connections with user authentication. And that's indeed what I've done here. I've logged in, I'm over an encrypted channel, and I can start to get to work. Now, to get started, the first thing I'll probably want to do is, well, we said we put, the SiteSync software is putting all the PVs right into the scratchpad. I'm going to go right away and take a look at some of that, some of those scratchpad areas. And the Groove Manage interface, which is basically your interface to all the applications running on the Epic. I'm going to go into IO, and I can see they have some IO channels that are configured. But I'm going to go right into IO services and take a look at the generic MMP map. In this case, I'm looking at the float area, and I see all those PVs coming in. And they're all going into a certain, Opto MMP address, as we call it. It's just a hexadecimal address. Somewhat similar to some degree as a Modbus register, but it's just one big floating point area I can put documents in or put data into. So that's terrific. I can see lots of stuff coming in, but now I need to know, well, what register area, Opto MMP address, is associated with which PV? Well, that's kind of cool too, because now I can come back and I'll go back to all the way to the home and go into the system, and the system itself has its file area as I described earlier. So I'm just going to go into the unsecured files area here, and look at that. I've got a SiteSync data.json. And in here, I can open it, I can download it, I can do whatever. So I'm going to go ahead and download that file. It's going to ask me for a place to put it. I'm going to put it where I've put all my other tests. Every time a new sensor is added, I just go look at the JSON file, and I'll go ahead and open it up here. And let's go ahead and make that a little easier to read. There it is. So there's all the data that the SiteSync software is pushing into the memory map and a JSON file, which is kind of like a dictionary file, kind of gives me a sense of all the different sensors, all the information, and their MMP locations. So I'm going to scroll right to the bottom, and the latest one you put in there, I'm going to guess here, Sarah, it ends in B988. Is that correct?
Yep, that's correct.
Okay, and that's a Vega Air. And it looks like I've got some a bunch of values that were the cool thing about the values is it kind of lets me know what the format of the data that's coming in. So I can see that, but that's not real time. That's a snapshot as when it went online. But here's all my memory locations there. So now that I have those, I can get started on actually integrating that into some of the software. So I'm going to go back over here to Groove Manage, and I'm going to go to the home page. And as I said, yeah, go ahead.
Can you go back and just show us what's the address, and then go back and show us the address in the MMP location?
Yeah, sure. So we'll just take one here, this measured value. So that ends in 203 Charlie at this address, right? So I'll go back to here. We'll go ahead and look at the IO again, go IO services. and look at the scratch pad, come out to 202 Charlie. Is that what I said? 202 Charlie?
Yes.
Let me just look. 203 Charlie. 203 Charlie, right there. 3137. So that's the data stream, the process variable that I'm getting from that device. Okay. So let's go back to home. I'm going to go into controller here because, as I said, you can have a number of different control programs running. This case, I am running the PAC controller. I can see it's got a strategy in there with a couple running charts. So let's open that up and take a look. And again, because I have access through the VPN, I can actually get to the control strategy running right on the Epic. So I'm going to open that up here, and there it is. Very simple flowchart-based control language. I am using some Opto script here, but I've got a little bit of pump logic in there that's we saw on the Groove view screen where I can start a pump and get a feedback. And so I got traditional I/O and a traditional program running on this device. A very, very simple one for sure, but to illustrate that we're doing basic control. Then I have another chart here that is ingesting the LoRaWAN data through that MMP area. And it's pretty straightforward. If I double click inside, it's a pretty simple mapping. What matters is I want to give it a tag name right here and the memory address it's coming from. So what am I doing here? I'm actually using a command, a pretty simple MMP read status command that pulls the data out of that register and moves it into a variable that I define. Okay, so in this case, some of the stuff that we've seen already on the Groove view screens, sushi pressure, sushi vibration, sushi temp, some of the Vegas, and so on. So now they've just added another Vega. And remember, it was B988, right? So what I'm going to do is, and we're doing this all on the fly, I'm going to copy the previous one here just to make things a little simpler. And I'm going to go ahead and paste that in here. Now I'm going to change some of this stuff to just say, well, actually what we're getting here is the 988 sensor. And here's the, I want to change all these tag names. So I'll go 988. And I can go ahead and edit all this. But just for the sake of time, I actually did copy all this information over to another file. So you guys don't have to sit here and watch me type. I'm going to grab that right here and go back to my program and just paste it in so you don't have to watch me type. There it is. So 988, all there. And I've already, to save some time, I have all my register areas there. So there's 203 Charlie, 2038, 2040, and 44. So that should be all the data I need. But what I haven't done yet is actually create these variables in my control program. That's easy to do. I'll simply highlight one of these here and see if I can. My mouse is a little tricky on this guy because it's so big so that you can see it in the Zoom call. So I'll just go ahead and copy that, and I'll go to numeric variable and add it. And these variables were not in there before, so I'll just make it public. Now this make public is pretty cool because once I get that information in, created a tag name, and make it public, that means that this data variable with this LoRaWAN sensor PV will now be available to any OPC client and also be able to be published to an MQTT broker over SparkPlug-B or MQTT strings. Just by virtue of making it public here, it's now accessible to any other applications on the Epic or external to the Epic over secure channels.
And you're not doing it via FOD8203C, you're doing it as a readable tag name.
Exactly. I'm taking that notion of this decoded data and I'm moving it into a tag that's hopefully everybody can understand. So, and then I'll use that to build other applications. So let me go ahead and grab another one of these. I'll quickly add these variables and paste that in, make sure it's a float, and make sure it's public. Whoop, I didn't make that one public. Air lithium 988, double click, no problem, just make it public. Okay, and I can also make these write capable. So not really suitable in this application, but indeed, yes, you can make data points writable as well. So that was 980.
That just means that from, say, SparkPlug-B or from some outsource that I'm publishing that tag to, I can now write back and change the value of the tag.
Exactly, based on the certain rights and so on. Yep. Okay, so I've got a couple of them in there: air temp, air angle. I'm trying to walk and chew gum at the same time. And we'll go ahead and add that last variable.
While you're doing that, Benson, just a question that Jeff asked, and thank you for everybody who's putting questions in. We're going to make sure we answer them all when we're finished. But I want to just grab this one real quick. Jeff's just because I was thinking the same thing, Jeff. You know, are we following a strong UNS architecture here? I believe we are. The only question I would have there, yes, it's lightweight. Yes, we're open. Yes, we're edge driven. Report by exception. So we talk about LoRa Sensors. My knowledge isn't high enough to be able to say yes to this, but we're obviously not polling the LoRa sensor. But I don't know, is the LoRa sensor set up to report on exception, or is it set up to report on a certain interval?
It depends on the LoRa sensor. Some of them are on change, some of them are on interval, and some of them are both. So it just depends on the sensor you have. But as data comes through from the sensor to the thing, we write it immediately and it's accessible to the Opto.
Thank you.
There are
Thanks,
some,
Jeff.
just to tie into that a little bit, right? There's, go back to the water district. There is a sensor that they're considering that, right? It's a submersible level sensor, but the sensor is smart enough to not publish or poll that sensor unless you get out of bounds. So if you're within a normal range, the sensor just operates there, will give a check-in. But then once it goes out of the normal bounds, it will start publishing or polling every 5 seconds or 10 seconds, whatever you set it up to be, right? So there's some smarts that, depending on which sensor you buy, just no different than anywhere else, right? And you're going to pay a premium. Obviously, it's going to be close to $1,000 transmitter than a $500 or $400 transmitter. But you have those opportunities, and the growth in the LoRaWAN space and the people who are stepping into that space, it's just going to get better and better.
Yeah. We'll talk a little bit more about some of the sensor details to answer some of these more questions. Benson, thank you, sir. Back to you.
Yeah, no worries. Thank you for the mental break. So the next thing that's important here is, well, how is that data exposed via OPC, MQTT,
Hey,
and so on?
real quick, Benson, I'm sorry.
Yeah.
I know.
No
Can you just go back to PAC Control, go into debug, and show me the values?
Sure. So I'll go into debug. Debug is kind of pseudo online mode, so I can actually see things that are running in real time. And I can see that my strategy and my chart is running. So now if I go to the Vega Air, let's go to the level. And I pull that up. Right now I am getting a 0, and I am scanning that. So that's a good question. I'm going to go back to my my IO. Actually, what I'll probably do first is that JSON file. I want to go ahead and take a look at that real quick. I can see that is at 3 Charlie. That's the MMP location. And go back to 203 Charlie for the measured value. Okay, so I'll go back to my PAC control program. We'll take a look inside here, and that is from 203 Charlie. So good question here, why I'm not seeing that that data in here, but let's go. Oh, I've got an error. Let's see if I can figure out what that is. Give me a second. And it looks like I had a couple errors there. I'll go ahead and clear those out. Yeah, it looks like I was having a little trouble getting to that MMP address. So let me go ahead and clear those messages. And I'll get back to that. So good question there. Why I'm not, I'm going to go ahead and punt. We're going to look at some other data there and just want to confirm that that's my read status, Epic IO, that is the correct address, and air level 988. Okay. All right. So we're going to move on, and I'm going to go back to my other application now. And we just want to see if those tags showed up into my groov, groov manage or groov view application. So here we'll go into groov view. And this, of course, is the local HMI. This is on the device itself. So indeed, what we're talking about is an HMI that's fully HTML5 compatible. Everything is, you can, whether you have an iPhone, iPad, Android device, anything with a browser is going to be able to view this information. And indeed, as we saw with Jessica and Sarah, it even goes to the front display on the Epic. So the same screens that you see here can be, distributed anywhere on that network or on the device itself. Indeed, one other nice feature is the Epics actually have an HDMI port. So I can take a standard HDMI monitor, plug it into the Epic, and get a big screen version, just like you see here, directly on that device. So while I have a apparent issue with getting to the that MMP area, which I'll take a look at in a moment, let's talk about how we build these screens. So in here, I can see that the build environment is actually within the browser. Okay, so we have a browser configuration, all here, all my gadgets, my devices, my tags, my OPC UA server. Again, that OPC server is already running, and all that data is already exposed to the OPC. So that's all I really, go ahead.
License to get this software, is that right?
10,000.
10,000?
Yeah,
100,000.
It's free. Everything that we're talking about here has no licensing. Well, SiteSync is a different story. They have their own licensing. But all the applications that are running that I'm using in this demo, Node-RED, PAC Control, CodeSys, all of it is included with the Epic. There's no additional licensing charge, and there's a nominal licensing charge for SiteSync. I don't know what that is.
So I have to have my maintenance current and pay my support annually in order to have access to this application?
You did when you bought the Epic. All support is free. All firmware upgrades are free. All pre-sales engineering support's free. Training is free. Everything is included with the Epic. So,
well, certainly you must be outsourcing your manufacturing in order to be able to do all this, Benson. How are these for softball questions, by the way?
I'm in the studio looking through a pane of glass that goes right over to our manufacturing. Everything you see from an Epic perspective was designed, developed, and is manufactured in this building in Temecula. We're 100% made in the USA, and we do everything from the software development, hardware development, manufacture, sales support. Everything is done out of here in Temecula.
Well, then to keep your labor costs down, I'm assuming you're not doing a whole lot of testing on your units before you ship them then.
Yeah, that's the beauty. Labor costs are our challenge. So the good news is we eat our own dog food. So we've actually developed all the test equipment for all of our devices internally. What's more is every single product we make, every one of them, from our little solid state relays to groov IO modules to the Epic processor, all of those are tested and burned in before they ever hit the shelf. That's why we can provide lifetime warranties on all our solid state components, any solid state relay, any solid state based IO module, guaranteed for life. Anything fails, we'll replace it. It's because when we put it on the shelf, we knew it worked. So
yeah, but you guys are still a new company that've only been around since 1985.
Yeah, we're kind of new. We're coming up next year. We'll celebrate our 5th decade. So yeah, just 5 times 10. I guess 50 years. Yeah, we've been around almost 50 years.
Sorry,
and I've been here for 28 of them.
Sorry to our audience for the cheesy infomercial, but those are things that Alan and I know really well about the Opto as a company. Benson won't talk about it because he doesn't want to be an advertisement, but that's something we think you should probably know.
Yeah, I'm even though my title is marketing, it's the other part of my title is product strategy, and that's what I enjoy most. So again, we kind of got a little off track there, and that's fine. I love the questions, but same idea here. Now I just go ahead and tie to the new PV values. So now those hopefully have popped up into my OPC UA server, and there they are. So there's the 988, which I'm probably going to get a 0 because I have some errors going on. But again, all I do is go in and make a few slight edits to that particular device. So we'll go B988, and we'll do the same with each of the. I can go through and do the same, but you get the point. I think what we'll want to do is let me try a couple of them just to be sure. I'll go ahead and grab 988 for the bar angle. There it is. Update the gadget and change the text. And the good news here too is as I'm making these changes, I haven't saved anything yet, but when I do, those changes will automatically be reflected over on Jessica's and Sarah's Epic and any other clients, HMI clients that may have been connected to it. So we're going to go to the lithium cell. We'll update that gadget, change the text. And finally, we'll do the temperature. Again, I do have a technical problem that I'd be happy to debug, but for the sake of time, I think what we'll do here is go right here to 988 for the temperature. So that's pretty much it. I've just duplicated one that was there, but you can see how easy I can just, drag gadgets on the screen. And that's all I did here. I just had a text box, text area. I drag it on the screen. I tie it to a tag and I'm done. Once I've made all those changes, and I just have, I'll go ahead and file and save all changes and then switch back over to the groov view side, which is the runtime. And there I'll get it. Now, oh, there I am getting data. How about that? Okay, so there you go. Now what we've got is the new 988, B988 Vega level sensor. The level is pretty high. The angle is 171 and the temperature is 22. So what we've done, just to recap here, I've taken all of that data that's coming in from the LoRaWAN sensors. Well, more specifically, I've taken a sensor, I've QR coded it, that added it into the app server running on the Epic, and then that app server automatically drops that data, all the PVs, directly into register areas I can get to. Then it also simultaneously wrote the JSON file, so I can do whatever I want with that JSON file, and I'll show you something kind of cool there too. And then I've been able to integrate that into my control narrative. And then by virtue of adding that tag into my control narrative, that data point is now available to anything via OPC, MQTT, whatever you want. That's all taken care of here at the data service. So I can publish the tags as MQTT, strings, spark plug payloads. I've already got the OPC UA configuration set up. So any other client external from the Epic can come in and get that same data with those same tag names. So if we talk about UNS and the Unified Automation Framework, the idea is I create that very last part of that topic of that UNS space, that namespace. And then we take that tag and then we start to branch on the other topic areas to make it fit the UNS and the UAF. So again, it all comes down to that single source of truth. And that single source of truth right now is that tag name. So now that we've got all that in there, go ahead. Another question?
Nope. Just an agreement. Just an agreement with you.
Good. So real quick, I did everything with PAC Control. I showed you some stuff in the groov HMI, but Terry did something really cool, and he literally did this in a few hours. I said, Terry, take that JSON file that the SiteSync software has delivered to us and parse that thing out. And you know what? Squirt it back into the PAC Control program or make it available to anybody who wants it. So he did. If I go in here to Node-RED, Node-RED again is resident on the device. Think again, the smartphone. It's just another app, and it can get to all of this data as well. So we go ahead and open up the Node-RED editor. And inside there, I can see I've got a pretty simple flow that's reading the file, the JSON file, parsing it into JSON, and then it's just sending it right back down, in this case, into the controller. So I can put it anywhere I want. I could easily drop I don't have my node palette up here right now. Let's pop it out there. But I could grab any of these nodes and do interesting things with this data that is outside the control narrative, right? Here's an example. I want to know if that Vega sensor exceeds a given level, I want to send a text message. Well, you drop a Twilio node in here and you take that message and you say report by exception. If it exceeds that, send a text message out. And we're doing that with our live Opto turbine demo that's been up for years. Every time somebody turns that turbine on or off, I get a text message. So, which is a lot, I might add. So again, just another piece of software that's being able to ingest this data and do something interesting with it. So that's the case of Node-RED.
Benson, let me interrupt with a question. Doug was curious about how you might be able to reduce the overhead of adding the PVs. Do you see Node-RED as a way to be able to do that so that we could do a bit more of an auto discovery?
That's such a great question. So indeed there is. I think what we tried to convey here is the notion of bringing a LoRaWAN sensor and getting into control strategy in some way that we could all pull together. Literally in the last few weeks, we've done this. But I think this is just the start. So I don't even know you want to consider it beta, but it's the art of the possible. So now we've decided that. And as Jessica just described earlier in the call, her job is to make things even simpler, right? So that's our next task. How can we start doing things just like Doug's question? And that is, well, what if we could do auto discovery? And indeed, we kind of can, because look what Terry did with the node red. He actually created the tag names based out of the information from the JSON. I'm not using those tag names because I was taking a different path. But now that that's there, I could potentially go 100% into an auto discovery mode. So,
okay, so hang on, Benson. Let's just make sure we understand what we're showing here. So you're looking at a groove view, and ultimately what Terry did was he parsed that data and dropped it into a table inside the PAC control, correct?
right.
And that table is now tied to the MMP address and the tag name. So now you have a dynamic mapping table for that and the device IDs available right in PAC control. So you had brought it into the scratch pad, went into Opto, you did a script that grabbed that data and then tied it to a tag, and now you have the tag. What Terry did was he just said, and eventually I assume you could just be watching for that file to change.
Oh, he does.
And that file changes, then you get the new data, right?
That's right.
All right.
Like I said, there's a lot more we can do with this.
Why are we going to be answering some questions? Maybe what we need to do is scroll to the bottom and let's see what we have here.
Oh, okay.
Let's go back and look at your mapping table.
There's
So the last thing
988.
you've got is that 988 sensor. You've got an 08C. Is that something different?
Nope, that's 203 Charlie, just as we had
Okay.
before.
So let's do this. Why don't we start to answer questions? Jessica, I don't know if you have a sensor available, but if you have another sensor you can scan, let's go ahead and scan it. We'll answer some questions. Let that syncing process happen. It doesn't happen instantaneously, but and then we'll come back. Nobody doing anything other than answering questions. Sarah scans it, and then we'll see if the thing pops in. Because if it pops in, and I know I'm putting Terry on the spot, I know I'm putting everyone on the spot. The whole point of this is a live demo, right?
Right. So why not throw some curveballs at us? I will say right now that this particular screen I built is only getting 18 of the indices of those string tables. So I won't be able to show it to you here, but I will be able to show you that coming into the PAC control program. Terry, I know when you were writing your code, you also had the limitation. So I think we were at 18. So I may have to, we'll have to make a few changes. We set everything up for this demo, but that's exactly how it does work. So we just have to expand the tables for that. And that'll take a little more time.
Okay,
go ahead.
Cool. Questions coming in.
The last thing I wanted to describe was here in the architecture. Now that we've done everything on-prem, where can it go? And I think this is important because now that we're at the Epic, we provided a local on-premise solution for the operator to scan a QR code, to get things up and running, develop the control narrative, create an HMI. But ultimately, we want to get that to other places that can benefit from this. Could be Flow software. It could be Canary Historian. It can be an Ignition SCADA system. All of those support MQTT, and all of this happens securely. So even though I have these devices on the back end of the Epic, and in this case too, the MultiTech gateway in its own secure environment, that 192.168 address is a non-routable private IP address space. But over a cellular radio or whatever, I can start publishing that data into infrastructure. Right? So we're not tightly coupling Flow software or Canary or Ignition directly to the Epic, and even more importantly, not directly to the MultiTech gateway. We've decoupled that through an MQTT architecture. So I think it's important to know it's great for on-premise, but it's already giving you the stepping stones to democratize this data to any application that can use it. Great.
Okay. Benson, question came in about using Rio for this application.
Yeah, thanks, Adrian. That's a great question. So yes, there's potentially this could work on Rio as well. So what is Rio? This is Rio. It's just a little remote IO device, but it is completely self-contained. It has its own Groove Manage interface. It's just a different product in the sense that it has fully configurable IO, but it also is running a Linux OS. Now, the big epic over here is a quad-core Linux processor, ARM-based processor. The Rio, on the other hand, is a single-core ARM-based processor, but still running the same Linux OS, and again, has a lot of applications on there. So theoretically, yes, we open up shell access, Sarah and Jessica upload their SiteSync software on there, and we'll give it a try. I have a sense it will work pretty well. The application that they've written is in Java and a little bit of Python. All of those are supported on both platforms. So theoretically,
the difference is going to be in the Epic, you have a control program, whereas with the Rio currently you have Node-RED, and you can also publish those out via, you can treat it like a remote IO, right? So you could put the Rio next to a gateway out in the field somewhere. That Rio can then the Epic can then get all the IO out of that Rio and incorporate it into its control system or PAC control program. Ultimately, as far as the actual size of the Rio or the capabilities of it, we don't feel there's going to be any limitations there. It's just a matter of, again, you got to get the module, get it on there, and then once you have the module on there, you can use Node-RED to do what we're doing here and extract that JSON file, create tag names, and then publish those out through MQTT or remote IO.
yeah, it's a slightly different use case. And the Rio is, a little less expensive than the Epic, but yeah, you're on the money there. So it certainly serves as a gateway. We do have Rios also that run Ignition Edge. So, and the Epic runs Ignition Edge as well. So, and I think that's an important point to make here. The work that SiteSync has done didn't just start here. They've actually developed an Ignition module that fits into the Ignition platform that does a lot of the same lift. Here's the difference and why we did it this way. Instead of using Ignition right on the Epic to facilitate getting all the LoRaWAN sensor data into it, that made it a challenge to get it back into the control program without a lot of, heavy lifting. So it certainly can be done, but also there's a license associated with Ignition Edge and so on and so forth. So what we're trying to do is figure out, well, how can we do this, but not necessarily do it all through Ignition Edge, but actually do it right at a core level where all the applications can get to that data.
Yeah, but just to go back to the Ignition piece, if you were wanting to get LoRaWAN Sensors into Ignition, SiteSync has the module, and what's cool about it is, right, so because you're dealing with the UDT structure, it will build out, so you scan the QR code, it configures the sensor and the MultiTech, and then it builds out a UDT structure in Ignition that has all of that data associated with it. So
yeah,
we got to go ahead.
I'm actually programming on the fly, so you guys are talking.
Questions, Sarah and Jessica. There was a question about, hey, can we get a demo download trial version? Is that available through the Ignition Marketplace to be able to do a trial of this?
Yes, it is. Yeah. You can go that route, or you can reach out to us on our website and we can get you a demo version. We can also do a demo for anybody's team if they are interested and want to communicate this to other people within their company. So yeah, we are willing to do that. You can reach out on our website.
And we are
I'm sorry, will you drop contact details in the everyone chat? That way it's easy. And we'll publish that information as well with the recording. Recording is always going to be on integratelive.com, including all of our other previous episodes, integratelive.com to find those. Price point test. I'm sorry, go ahead, Benson.
Terry, just let you know, I expanded those tables to 32 indexes.
Price point of the module. What's this cost? Is it perpetual? Is it annual? Oh.
Yeah, so it is, it's a perpetual cost, but it has an annual subscription with it if you want to be continually getting more and more sensor decodes. And so it is, perpetual, but then you get more per year if you're paying that annual fee.
Okay. Do you have any pricing available that we can share?
Yeah, so the pricing, what are you saying for ignition?
For ignition.
Oh, yes, yeah. So you do have to have your ignition license to do it through that. And then that's on our website as well.
For the Opto, we're not sure. It is brand new, so we will see and we'll get back to you.
Yeah, so we have
Okay.
our pricing for our ignition version, but Opto, we are in progress.
So for the audience, like this all came together in just the last 5-6 weeks as a result of Opto and SiteSync being side by side at Intellect, essentially sharing a wall between their booths. And Alan walked by and a conversation started, and it was like, hey, why don't we do this and build this out? So what you're seeing is been as a result of that conversation and has come together to do it outside of Ignition just recently. And I really appreciate the work that you all have put into making this happen.
Yeah, it's the beauty of Intellect, right? You get a lot of like-minded folks in a given industry, and we get to see each other's solutions. And I think that's a testament to what Integrate Live is and what events like Intellect are, is this notion that, hey, it's not all just about competing against each other. What if we created a more collaborative environment? And indeed, a shout out to Intellect, they created the Innovation Lab, which was essentially a big plug fest where everybody was able to exchange data from their booths through an MQTT architecture. And SiteSync was there, we were there, were many others, all sharing and publicly sharing our data through this infrastructure for others to consume. So you had Ignition there, you had Canary there, you had Iconics there, all connected to that same infrastructure and pulling all this data in, whether it was LoRaWAN, whether it was our own little beeper on our Epic, flows, pressures, you name it. But then again, Integrate Live actually starts to show us how we can do this, right? At Intellect, we kind of said, here it is, isn't it cool? Integrate Live says, well, how did they do that? And that's why we're here today.
Right. Yeah. No, we've had a great time working with Opto 22, getting all that together. I think it's such a new industry too that we want to partner with people and offer our customers as much as we can.
A question came in around, I'm sorry, I'm just going to keep the questions. I'm going to advocate for the questions to get answers. Question came in around how MQTT plays into this architecture. Now, Benson, I think you did a great job of showing us once the data gets into the groove that you at that point are just going to act as a hub and publish via out MQTT. We could do that spark plug. You could get that out OPC UA. But Sarah and Jessica, specifically, is it once the LoRa sensors are communicating across the LoRa protocol to the MultiTech gateway, then MQTT is typically used to go from gateway to where
It depends wherever your app server is or however you want to consume that data. So in our case, the MultiTech gateway is MQTT to a broker. I'm subscribing to that and doing the decode, and then we can publish it. We can do whatever you want after that point. So in this point, we're doing it to the MMP area.
And if I can interject there.
Oh yeah, go ahead, Benson.
Yeah, it's really cool. And a lot of people just think about MQTT as, some client or device publishing into some cloud broker or something like that for others to consume. And indeed, that is, the largest use case for MQTT. But what they're doing is its own MQTT network at the OT layer. So the communications between the SiteSync software running on the Epic and the MultiTech gateway is indeed MQTT, but at that level, down at an OT level. So I hope that makes sense, but it goes to show you the value of MQTT. It can be deployed cloud environments, big on-prem environments, or right at the lower level of the OT environment. It can be used in any one of those cases.
And I just wanted to mention, we're also working with Sparkplug making that connection from the gateway down at the device level all the way up. So transmitting it through all the way up, which is really cool, getting that statefulness on those devices.
Yep. So Sparkplug B is coming.
All right.
Brad offered, I think, a good supplement to the statement that I made. And I'm just going to, because it's outside of my depth, Jessica, Sarah, confirm for me. LoRa is the wireless technology, but the protocol underneath is MQTT. Even in the line of sight communication, is that correct?
LoRa is radios using MQTT to talk to each other. So it's like an extension of MQTT. It uses it, but it's its own protocol.
It's RF. LoRa is the RF piece, right? It's the radio frequency talking from the sensor to the gateway radio via RF. And then once it comes into the radio gateway, then it is decoded into the LoRa protocol. And then you have to take that LoRa protocol and do something with it. And that's been really the pain point, right? That we've talked about earlier is once you have that decoded from RF to the LoRa protocol, you got to now extract that into something usable in the OT space. And that's what we're doing today. We're allowing the work that SiteSync did, scan the QR code, and then it just shows up in a protocol that the Opto can consume and then do whatever you want with it at that point, right? So we're really solving that pain point in that middle, right? You saw the configuration to configure the gateway, right? Put your IP address in the gateway, your API code, key in, and then once you have that connection, start scanning the sensors, and those sensors will populate and move into your Opto, and now you can start doing, or into ignition, whichever way you want to go. But it'll just happen, right? I buy a Wise camera, I turn it on, I download the app, I put my phone in front of the camera, I get a QR code, and then boom, it's on my network and everything's great. I name it, same idea.
Thanks, Alan. There was a question that came in from last week via email to me after our rundown, talking about positioning LoRa in non-dispersed asset environments, right? So we've talked a lot about remote assets and the hard to get data from. The question came around on what about inside the factory walls? And I think, Jessica, you might have mentioned in the beginning about this concept of the benefits of LoRa inside of a factory, right? Have you seen deployments inside a factory? Are they still using batteries on those sensors, or are they hardwiring sensors so they can get a much faster update rate?
So we have seen applications where we're getting wireless penetration within the walls of a industrial setting, manufacturing setting. So yeah, we have seen it working. We've seen the sensors coming through difficult obstacles back to gateways. And so yes, we have seen that.
And then the radio transmission, it doesn't get any faster sensor wise, but if you wanted to plug your gateway into Ethernet, like that would be a more stable thing. But your sensor itself, as the network effects take effect, so you have a lot of sensors in your network, it'll extend it and make it stronger.
And then one of the things that in a remote or a distributed environment you have to kind of balance is that concept of how often do I check in versus my battery life, right? Like we don't want to be going down and changing batteries all the time. But if we're in an environment where we have power available to us, am I right in saying that some of these sensors allow us not to rely on battery? We can actually use the power source.
Yes, some of them, you can plug them in. They could use a host, whatever they're working on. There's one that's like a utility hot drop that just takes whatever it's measuring, it powers the sensor, which is really cool. Mm-hmm. So lots of options. Whatever your business case is, there's probably a solution for it. Mm-hmm. It's all modular and customizable.
Right. Yeah. It's just a matter of, reaching out to us, letting us find something that fits your needs, and then us adding it to our decode library.
Yeah.
There's a question around batteries, right? And so there's some questions around, are these sensors? So yes, they're wireless battery operated. They have an internal battery, which nice. It's nice about that is, like, say if you're gonna do vibration, right? You buy your vibration sensors, it's got a magnetic base. You scan the QR code, snap it on your pump, and you're off and running. No conduit, no wiring, what have you. And so it all depends, like every wireless battery operated sensor, everything depends on how often you need that data. If you need it every hour, if you need it every couple of days, you're talking years. If you need it every 5 seconds, 10 seconds, you may be talking, a year or less, depending on how you need that data and how you want to do it. And that's why the water district here in town is looking for an opportunity to say, hey, I don't want to publish unless I'm within these bounds, right? And so there still has to be done internally on the sensor to check that level. but ultimately you're going to save quite a bit of battery life by not having to publish out that every 10 seconds to get the level. So
Yeah, exactly. No, it is a balancing act. The typical is about 3 to 10 years. And if you're reporting by exception, you can be on the longer end of that range.
we're OT. We don't do anything in years. We do things in seconds.
Right. Yeah.
Go ask a control engineer. You okay getting this every 5 hours? Yeah, probably not. The option is there, right? And it's really this comes back to Jeff, you're going to appreciate this. This comes back to a time series historian issue, right? What did we do in the control system space? What do? We said every single tag I want to update every 5 seconds. And then we bombard our databases with tons and tons of data that's unnecessary. So it all comes down to make sure that you're doing your due diligence to know what the data is, what you're using it for, how you need it, how often you need to get updated, and go about that business. Because what will happen if you don't, the default say it's 15 seconds. We had this happen, right? I'll give you a real quick use case. We deployed the Rosemont gateway and hundreds of sensors across a field to get some surveillance stuff going, hundreds of sensors. And we did this project, we got the money, we deployed it all out, got it all working. It was great. Everything was awesome. And then 2 years later, one day, within a matter of about 10 hours, we lost every single sensor. And then guess what happened? It was a mad panic to find batteries, get bucket trucks, get all these things so we could get these things fixed, right? So it's it's the whole cost of ownership. It's what's it going to cost to get it in? What's my maintenance I need to put in for the battery? How often do I want to go and service this thing so I make sure the battery's up to date?
Definitely. Yeah, the sensor manufacturers can get you a pretty good calculation of your projected battery life so that you don't end up with it dying before you realize.
And some of them report their status, their current status. So you saw on Benson's screen, he had capacity or how much battery was left on your thing.
Yeah, but if it's a lithium battery, it's going to tell you it's good, bad.
Yeah,
we've had that pain.
Yeah. Benson and Terry, the Vega ending in A08C was added and checked in. So just keep an eye out for that over there. So yeah.
I'm looking at the table now. I'm happy to share my screen if I have success.
Yep.
Not yet. Terry, you need to read the JSON file and squirt it in, but
To our audience, I want to let you know next Wednesday, we've got a special webinar that Integrate Live is hosting. It's not a project we're building. It's a webinar we're hosting. Kepware, Dell, Intel, Insight, and Wachter have worked out a coalition of offering a hardware and then services solution to try to make it easier to go after edge data and turn it into insight. They're going to do that announcement live next week with probably what I think is going to be a 30 to 45 minute webinar in total with Q&A. Would invite you to register for that and attend. It is in the afternoon, 1 o'clock Eastern time. And I've just dropped a link to register for that if you're not registered into our chat. Would appreciate you registering, attending, or registering and grabbing the recording after the fact.
What chat? Other questions? Something with Chat GPT also, Jeff?
Well, that's in October. That's in October. The next virtual workshop, if we want to start talking about promoting that, will be working with Kepware, InfluxDB, Software Toolbox, and Phoenix Contact to grab data, bring it up, run analytics, and then bring it the entire way back in, complete the loop back into the device and do something cool with it on the Phoenix Contact side. So more around this concept of, hey, you need a PLC, invest in a PLC that's going to allow you to do more, just like what we've seen.
Yeah,
that's next gen PLCs. Okay, so a few more questions that are still out there hanging. We want to make sure we get answers for. There was some conversation around seed. I want to make sure I'm saying it correctly. I think it's seed. Looks like there's either 3 E's in that or maybe a typo. Studios having a lot of very low cost LoRaWAN sensors. Any experience with that from the group?
No, can't say I've had experience with seed. I've been mostly industrial manufactured sensors, but be interesting to look at.
Keith had a question about, hey, how do I take a non-native LoRaWAN capable, how do I take a non-LoRaWAN sensor and make it LoRaWAN capable?
I can answer this one. You
Yeah.
buy a non-LoRaWAN gateway that talks to that sensor and then figure out how to decode it. No? You got a better answer?
Yeah, we have a Volibos Bobo on our website, and you can use that as a bridge. So you can bring in Modbus or 4 to 20 and backhaul LoRaWAN. So it is possible.
Mhm.
All right. I want to check that out then because I was not aware of that.
Yeah, it's a
Yeah.
bridge. It's really cool. Like Roger said, yes, it is a bridge,
Mm-hmm.
which is very cool. It has a lot of potential, a lot of cool use cases.
Yep.
Roger, thank you for your contributions inside of the Q&A. You had
Question on liquids.
question early about liquids. I'm not sure about the context. Does anybody else remember what we were talking?
I think he was asking about the Vega I showed, and so correct me in the chat if I'm wrong, but the Vega that we showed was for liquids, and then there are also Vega options that do bulk solids.
So
Cool. All right, let's see who else just came in.
Yeah,
so
8 Charlie came in.
excellent.
we got a question about 4 to 20 milliamp device. Again, LoRaWAN has multiple opportunities to buy a battery operated 4 to 20 sensor that you can literally wire tie it to a sensor, loop in the sensor to your 4 to 20 loop, and then you can publish that out via the radio.
Thank you, Alan. David was curious on whether mesh is supported or not, or is it only sensor to gateway?
I think it's just sensor to gateway.
Oh,
You can
Brad.
I think you can do some redundancy, but you have to do it at the gateway level. And
So,
I'm not
Brad-
sure how the RF side works with that.
Yeah, so
Okay.
the
Let's real quick just note Brad's response here. This is what I love about this community is we don't have to have the answers. It's a great way to interact and ask questions and get answers. Brad says, from his experience, if you have multiple gateways in range of the sensor, all gateways will forward packets to the LoRaWAN server. This is how redundancy is handled.
and these guys, if they're not joined, will send messages to any of the gateways, and whichever one it is joined with, it'll go forward it up to. So that's your redundancy. So one goes off, you've got another one in there. Thanks, Brad.
Okay. We're cutting off the Q&A. Let's see. I think was there something we wanted to show on the challenge that Alan made, or?
What, you don't believe me? So I'm just showing the data that's coming in rather than over to Groove View. I have it right here. The 8 Charlie devices are all right there. So they did come in through the JSON, and then they are all Vega Airs. So this is just a couple different arrays lined up. And so at that index, we can see that did join. And if I wanted to see the index for the MMP address for those guys, again, I'll pull that up and stick it right there in line. And then I can see for those 8 Charlie devices, those IP addresses. I am over VPN all the way, calling Baton Rouge to there. So it takes a little longer for that stuff to come in, but indeed, there's all my memory map addresses for those devices, starting right here with 11 and going down to here. So I can add that to my Opto script in this case, and create the tag names, and boom, that'll be available to all the applications, not only on-prem or on the device at the edge, but on-prem cloud and to visualization devices.
Great job, Terry. That looks awesome.
Thank you. Thank you for keeping the JSON structure consistent. That's having that JSON and scanning that is sort of the key to making this happen.
Yes. Very
Hey,
good.
I would, to the group, there's still a lot of conversation to be had here. Go to integratelive.com. I'm starting a chat thread around today's project so that we can, as a group, continue to discuss, ask questions, and get answers from the community about their experiences around LoRa. So if you have not joined integratelive.com, it's one of those 30-second processes. Use your Apple ID, your Google ID, your LinkedIn, I think is even supported. And then we can have these conversations, as well as this is where you can get all of the episode libraries and the upcoming event notification from. All right. Oh, and dad jokes. Lots of dad jokes get thrown around on those channels. So, hey, with that, Benson and Terry, thank you so much. You've put in a lot of time and effort. It went well today. Thank you. Jessica, Sarah, thank you for all the hours that you've burned on this. And Alan, thanks for being the impetus to put this thing together.
And thanks for
really
the curveballs,
appreciate it.
Alan. That was always throwing something new on the magic table all the
Yes,
time.
sir.
It's only because he knows you're up for the challenge, Benson.
Right.
All right. Well, to everybody, thank you so much for joining. Please feel free to share these recordings with your friends and colleagues. And we will see you hopefully next Wednesday on the webinar that kicks off at 1:00 p.m. Have a great day and keep building cool stuff and sharing it.